Hi, ladies. You'll be watching this Chapter 5, Day 3, starting on May 13th. I did throw in a day of Chapter 6 in the middle of Chapter 5, but this day is out of the purple packet. So today we'll have prayer and some updates, no prime time, reviewing answers. Class content is going to be going over covalent compounds, and we're looking ahead at classwork and what's coming the rest of the term. So we'll start with prayer and with the Our Father today. So in the name of the Father, the Son, and the Holy Spirit, amen. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses as we forgive those who trespass against us. Lead us not into temptation, but deliver us from evil. For thine is the kingdom, the power, and the glory forever. Amen. So, updates. There's only 4 days left. We've got Wednesday and Friday of this week and Tuesday and Thursday of next week, in which today we're doing covalent compounds. Friday we'll be working on some balancing of chemical equations. Tuesday, naming acids and kind of like a look back on all the naming. And then next Thursday, we'll just be practicing some of the final material. So test update on Chapter 4. I've gone through and updated your scores, fixed problems. Originally, the last 2 questions where you were assigned an ion or an isotope, it was not giving you credit for either answer. It was only giving you full credit if you had both answers selected, which made no sense. But I fixed that. I went through manually and did that. I also went and looked at all the average atomic mass calculations and made some partial credit adjustments as well as some full credit adjustments for people who were very close or just didn't have a space or something like that. There's one student taking the test on Friday, and after that, I should be able to email your results to you because I was told that you cannot log back in and actually see your results or see the adjustments that I might have made. I did also grade all your one-pagers that were turned in on Monday. So those who did well, they followed the rubric. So they gave enough examples for protons, electrons, neutrons, put the rules in there. And on the other one, they covered all the topics listed. There were a lot of people who did not cover all the topics listed and therefore ended up with a very poor score for the second one-pager. On the first one, there were a lot of people who didn't show how to do protons, electrons, and neutrons and how you figured those out. So they did a poor job. But the ones who did, they did a really great job. They looked great. They were easily read. They were a great study guide. And part of what was very interesting is as I was looking through those, the people who had all that information on their tests did better on the online test than the people who didn't have all that information. So, but I will be trying to send out some emails before noon on Wednesday to those whose grades on this section were not good because their one-pager didn't cover everything. So you can get some partial credit back if you choose to do so. So personal pictures. I took some pictures from our trip to China, which was quite a while ago now. But we visited Beijing and Shanghai, and there's the Pearl Tower here and building next to it, which I thought was really cool looking, where we saw a Chinese acrobatic show. This is a picture of the front of the Forbidden City and the Great Wall of China, as well as this building is the Bird's Nest, and it was being built for the Olympics. And we didn't get to go to the Olympics, but my husband did get to go to the Special Olympics and see a number of the swimming events, which he said was really amazing. And I thought I'd share these two because you may see these lions outside of Chinese restaurants and things, and they're either holding this ball or they have their hand over a little cub. And it turns out that this one who has the cub is a female, and this one who's holding the ball or an orb is the male. So what kind of interesting when we learned that when we went on a tour in the Forbidden City. But ever since then, now that we see these, I recognize that we see these in lots and lots of places. They're definitely been at the Asian Lantern Festival at the zoo and definitely a lot of restaurants around town. So you may see these now that I've pointed them out, that you may recognize that. For chemistry video, I recorded something over spring break with the help of my husband on a chemical reaction with pennies and hydrochloric acid. So for your homework, I'm going to ask you to note what of your 5 observations that we talked about previously allows you to decide that this is a chemical reaction. And I'm going to have to splice that video in here, so I'm actually going to pause the video for now, and I will resume after that demo is done. So I took some pennies and did a reaction with HCl over spring break, and my husband was a huge help in this. I want to go ahead and show you what we did. So we took some pennies. Any of them made after 1982 are made of both zinc and copper. So what we did was we sanded some of the edges of the pennies. You can kind of see here in the picture, and some of the kind of grayish edges here, because we were trying to expose some of the zinc that was inside. Hydrochloric acid will react with the zinc, but it will not react with the copper. So in essence, we were trying to make some holes in the copper that's on the outside of the penny. So here is our setup video. We've got a mason jar here with pennies in it, and we're going to pour some HCl in very carefully. My husband's pouring HCl in. I'll video it for a few minutes, let you see if there's any signs of any chemical reaction going on, and then we're going to seal it all up, move it, and but we're going to come back to it later on so we can see what's happening. So I think I need something colored behind it so you can see it a little bit better. So hopefully on the video you can see it's kind of cloudy. There's lots of bubbles there. I'll even try to take a picture of it if I can. All right, and we'll come back and check out the pennies later. So actually we never really we did not cover it, but I took a picture of it, and you can kind of see it cloudy here. So the reaction that's going on is zinc is in the solid state, and it's reacting with HCl, which is dissolved in water, forming a zinc ion and a chlorine ion, which is actually zinc chloride, and some hydrogen gas. So we moved this outside to our patio area so we wouldn't be breathing in the fumes, because it was actually kind of stinky. So you can see that here, and it looks like it's colored a little bit. It's become a little discolored. Here's another little video showing how much it's bubbling at this point in time. So you can really see the bubbles pretty clearly. Then at the end, we were left with still a lot of unreacted HCl sitting in the bottle or in the mason jar, and we needed to dispose of that. And since we don't have any chemical lab equipment here that I would have at school, we used baking soda in order to try to neutralize the acid. So we've got it set up with a bowl with a bunch of baking soda in the bottom. We're pouring a little bit of water in here very carefully and allowing it to spill over the sides, and you can see that it's bubbling here. So the baking soda is reacting with the HCl that's spilling over the edges of our container. Now, I realize that from a safety point of view, you really shouldn't be pouring water into acid. However, we decided this was dilute enough and this was the best we could come up with, but I wouldn't recommend trying this on your own. So what we did is we kept on pouring water in, letting the baking soda react with the HCl, so we no longer had a strong acid, and then we allowed it to go down the drain. So this is the reaction that's occurring here. So we've got sodium bicarbonate, HCl, forms table salt, water, and CO2. So CO2 is the gas that we're seeing here with the bubbles. Obviously, water is water, and NaCl is table salt. So what we end up with as it reacts is very benign, innocuous, and we can pour it down our kitchen sink. So what are we left with the pennies? So with the pennies that had been scuffed up really well, I took some pictures of what we were left with, and all we have here is the copper part on the one side. So you can kind of see in the pictures here, they're kind of curled. It's a really, really thin layer of copper, but still has the design imprinted on it. And we've got a few backs. We've got a couple of fronts. We had a couple of them here that had the back and the front still attached together. They were not separated. We did have a few that did not have all the zinc inside react, and that was partially due to what we think was not having them scuffed up enough. My husband was scuffing them up and thinking that he would scuff some up a lot and some up a little and see if there was a difference, and there definitely was. The ones that were scuffed up a lot seemed to have a much better reaction, and all of the zinc dissolved and reacted. So that's an example of one of the reactions. So hopefully you guys caught those observations that you can make in any NaHCl demonstration as to why that was a chemical reaction. So just write those down on a sheet of paper or add them to something else that you're turning in. It doesn't matter to me. Just make it clear that I can see it. So as I'm looking through, I give you credit for it. So as we're finishing up chapter 5 and 6, today we're going to be working on binary covalent compounds. But first I want to go over your homework from last time. So on purple page 17, when you were naming the compounds given the formula, I noticed in the homework that like 70% of the students who had turned it in when I went to look at it did not put the parentheses with the Roman numeral 3 in here, which you need to have because gold is a transition metal. It's in that middle section of the periodic table. And if you do not put that Roman numeral 3 in here, it is wrong. So, and the really surprising thing is I did this example in the last class. So you could have just copied it from the screen in the last class, but a lot of people didn't do that. So I'm not exactly sure why it wasn't copied correctly or why you didn't put it, but I wanted to make a note of it here. And then in the formulas for names, a lot of these were pretty good. I did notice a few people not even attempting to look at the charges, and so they ended up with some of these that had one of each atom. So like this one was AlCl instead of AlCl3. You have to look at the charges for these ionic compounds. If you don't do that, it's wrong. When I went through and did it, I first noted what all the polyatomic ions were here, so I would pay attention to those as I went through. And then I wrote out my charges here next to the answers so that you could see them. So pause the video, go through them. Any questions you have on this, put it in the survey. So I think we need to keep practicing some of these. So on pages 19 and 20 in the purple packet, 19 is given a formula, write the names, and 20 is given a name, write the formulas. And you should do as many of these as you think you need to do in order to be more comfortable. Everybody's going to be different. Everybody's comfort level is different. I also want to put the caveat on there. If you're spending hours and hours, you need to stop. Okay, I told you guys this back with the MOP apps, not to spend ridiculous amounts of time. There is a finite amount of time that you should spend on this based on what all you have going on. Do not go crazy. If you're spending hours and still struggling, then you need to stop and reach out to me because you probably need some more assistance. So don't spend hours and hours. I will be looking at these and kind of assessing how they're going, how you're doing, how far you kind of got. So that's homework as far as like reviewing these ionic compounds because they are the most difficult. So magenta, pages 5 and 6. So question 1, comparing terms, remember to use a comparison word. So first one was word equation and a chemical equation. A word equation uses the full chemical name, while a chemical equation uses the chemical formulas, and the chemical equation is shorter and more efficient. Reactant and product. So a reactant is a chemical present before the reaction takes place, while a product is a chemical that is present after the reaction. Reactants combine to form the products. Solid and aqueous. Both solid and aqueous are used to describe the state of chemicals in a reaction. However, aqueous indicates that the solid has been dissolved in water. Now, you do not need these word for word, but you should have something that's kind of similar. Question 2A, how can you use a chemical equation to determine whether a reaction needed heat to proceed? So you're going to examine the reactant side for information like heat or energy. For B, how can you use chemical equations to determine whether a reaction produced heat? And you're going to examine the product side for information like the words heat or energy. Question 3, what's the purpose of the yield arrow in a chemical equation? The yield arrow shows which direction the reaction goes. It clearly shows which are the reactants, because they're before the arrow, and which are the products, which are after the arrow. Question 4, write word equations for the following reactions. So the first one, you should have written copper plus oxygen yields copper 2 oxide. B, you should have written sodium hydrogen carbonate plus acetic acid yields water plus carbon dioxide plus sodium acetate. C, hydrogen peroxide plus light yields water plus oxygen. Question 5, consider the following reactions. Name the reactants. So the first thing is hydrogen nitrate, and then the next one is sodium hydrogen carbonate, and you should be able to name both of those. Naming the products, we've got sodium nitrate, water, and carbon dioxide. And C, what evidence suggests the chemical change is taking place? So in this case, if you started out with something dissolved, solid and an aqueous solution, and you ended up with a gas, you should probably have seen bubbles. You may not have realized that, and that's okay. Question 6, write a chemical equation from the following information. So C as a solid plus NiO as a solid plus energy yields Ni as a solid plus CO as a gas. So that's the complete equation for this. You might not have realized that carbon and nickel oxide were all solids, and that's okay. I do expect that you should have known that carbon monoxide is a gas because it tells you here right in the chemical equation. All right, magenta page 8, and this is on the other section about conservation of mass. So explain why the following situations don't disobey the law of conservation of mass. First one is the mass of a hamburger decreases as it's cooked, and that's because the water in the hamburger can evaporate. The grease could come out of the hamburger, but if you were to actually collect the mass of all of those things and add them together, you would still end up with the same total mass that you started with. The second situation is you're often lighter in the morning than you were when you went to bed, and that's because you respire or breathe, and you also perspire, as in sweating. So a lot of times you will weigh less in the morning than you do at the end of the day. Question 2, a 25-gram sample of compound A is mixed with a 40-gram sample of compound B. A chemical reaction occurs. Once the reaction is complete, the final mixture has a mass of 55 grams. What happens to this missing mass, and how much mass is missing? Well, you started with 25 plus 40, so that's 65, and you ended with 55, so that means you've lost 10 grams. And that missing mass didn't disappear into nothingness. It is probably going to be released as a gas because it's no longer on your scale. And question 3, what's the difference between a skeleton equation and a balanced equation? And give an example of each. So a skeleton equation shows the chemicals in the reaction, but not in the correct proportions, and so they would disobey the law of conservation of mass. So the example that was in this lecture just up prior to this was H2 plus Cl2 yields HCl. But in contrast, a balanced equation shows the chemicals in the correct proportion to obey the law of conservation of mass. And so the example here is H2 plus Cl2 yields 2HCl, which is given up here at the top of the page. So we're going to put aside the magenta packet until Friday, which is when I'm going to do balancing equations. So today, the rest of the day, we're going to be on the purple packet. So, warning. This is a new type of naming. It is different than ionic. You have to pay attention to the difference so you don't confuse them. It is really easy to confuse the two if you are not paying attention. So this is where it's really important to know the difference between metals and nonmetals. And there were a few students who have their periodic table colored incorrectly and hence missed some of this on the Chapter 4 test that they took. So again, the metals here are blue and they're on the left side. The nonmetals are yellow and they're on the right side. So we have two types of bonding. We've been talking up until this point about a type called ionic, which is when a metal and a nonmetal bond. So that means you have something over here from the left side bonding with something from the right side. Covalent is when you have two nonmetals binding. And those are things over here on the yellow side. So if you have a metal, it is not going to be a covalent bond. So if you have anything that's over here in blue, it is not covalent. So what happens to the electrons in here is really different. How we name the compounds follows totally different rules. So you've got to pay attention, which is why we went over this metals versus nonmetals back in Chapter 4, and because this is information that you need, and you're going to need to know this indefinitely in chemistry. So we're going to practice identifying ionic and covalent on purple page 21. So for all of these, we need our periodic table in front of us, and we need to ask ourselves if we have a metal and a nonmetal, which would be ionic, or do we have two nonmetals, which would be covalent? And note, anytime you have a polyatomic ion, it's always an ionic bond. So the first one, when we look at magnesium and chlorine, we have to look and see where they are on the periodic table. So we're going to put all on our periodic table. Magnesium is over here. Chlorine is over here. So this is obviously a metal and a nonmetal. So we're going to have to do that for all of these. So the first one is a metal and a nonmetal. It's ionic, and we have to count the number of atoms. There's two chlorines and one magnesium, so that's a total of 3. Number 2, there is a polyatomic ion and a nonmetal. So it's got to be ionic. And I count 11 atoms. So there's 4 hydrogen, 1 nitrogen in here, so that's 5. And there's 2 sets of those, so 5 times 2 is 10, plus 1 gives us 11. Number 3, aluminum and sulfur. Aluminum is a metal, and sulfur is a nonmetal, so it is ionic. So counting atoms is 2 plus 3, which is 5. The next one, H2O. H2O are 2 nonmetals because remember we look here, we should have colored in hydrogen to be different. Hydrogen is a nonmetal. So H2O is a covalent compound and there are 3 atoms in there. The next one, number 5, CO. Both of those are nonmetals, and so there are 2 atoms, so that's covalent. Number 5, magnesium nitrate has a polyatomic ion, so this is ionic bonding. So counting the atoms, there's 1 nitrogen and 3 oxygen inside the parentheses, so that's 4. We're going to multiply that by 2, so that's 8, and then 1 magnesium, which is 9. And then the next one, NaCl, that is a metal and a nonmetal, so it's ionic, and there are 2 atoms there. So I'm going to have you finish the rest of these for homework. So feel free to pause the video right now and just take care of those. So now we're going to work on naming covalent compounds, and we're going to start on page 22 in your packet. And just to let you know, students find these much easier than ionic. So that's why we do the hard ones first and try to keep on practicing them every day, a little bit every time, because covalent are much easier. But you've got to pay attention as to which one you have. Because now that you're going to know how to name all of them, they're going to start being mixed in on your worksheet. But for today, it's just these covalent ones. So, starting at the top of page 22. So, you're now exceptional at naming ionic compounds, or you're working towards being exceptional. So, recall, ionic compounds are made up of a metal and a nonmetal held together by an ionic bond. The bond is formed when the cation gives up the electrons to the anion, who takes the electrons. Another type of bond, it can be formed, is between a nonmetal and a nonmetal. So this type of bond is called a molecular or covalent bond. You'll see both terms used. In this bond, electrons are not transferred, but they're attracted to both atoms' nuclei. So the nuclei play a game of tug of war for these electrons, but neither actually wins. So in essence, these electrons are shared between the 2 or more atoms. And I've got a really cute video to show about this. It's dogs. So dogs teaching chemistry.
To Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by 2 atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
I hope you liked that video. When I saw that, I thought, oh, that was really, really cute. Actually, my daughter is standing here going, that was so cute. So for those of you who like dogs, hopefully you found that entertaining. Okay, so we've got Bohr-Rutherford diagrams, which we have not really studied these. However, you did draw some of these with your models. So this is just demonstrating what's kind of going on here. So the one atom here has only 7 electrons in its outer circle, and it would really like 8. And this other atom of fluorine also has 7 electrons in its outer circle, and it would like 8. So both of them would like to have 8. So they both want 1. So one says, give me an electron, and the other one says, well, if I do that, that doesn't help me. And so then our Professor Cat here says, can't you two just share? So if they share, they each share an electron, they end up both having 8, and that is a covalent bond. So now you don't have to worry about the details of this. You'll talk about covalent bonding next year. We're just going to worry about naming them, but I wanted to introduce to you what was really happening here. So this is fluorine gas, F2. I'm sorry, the text here is really light. I didn't change that. But that is the example in your packet. The other one, oh, so they're really happy in there, but they're stuck together. So the other one is H2O, and it is the same issue. So the hydrogens, remember, they're an exception. They only will have 1 electron, so they want to fill up their outer shell with 2. And oxygen has 6. 1, 2, 3, 4, 5, 6. So it wants 2. So it ends up having to bond with both of these 2 hydrogens in order to make it work. So this is what they do. And now both of them have a full outer shell, and so water ends up being H2O. So some definitions here. Molecular compound, a pure substance formed from 2 or more nonmetals. A covalent bond is a bond formed from the sharing of outer electrons between nonmetals. Molecule is a particle in which atoms are joined by covalent bonds. And a diatomic molecule is a molecule made up of only 2 atoms, and it can be the same or different elements. So go ahead and pause this and copy this into your chart. Diatomic elements, we have a whole bunch here, and you can fill it in, but we've got hydrogen, which chemical symbol you should know is H. It makes a diatomic molecule, H2, and it is a gas at room temperature. Oxygen, O, is O2, and it's also a gas. Fluorine is F2, it's also a gas. Bromine is Br2, and it's a liquid. Iodine is I2, it's a solid. Nitrogen is N2, and it's a gas. Chlorine is Cl2, and it's a gas. These are just the most common ones, and you will see these a lot in chemistry and in formulas and in a lot of science classes. So we're going to start with figuring out how to name the molecular compounds. So chemists have devised a separate method for naming molecular compounds, and it's actually very simple to follow. So first, you have to check that there are no metals in the formula. Let me repeat. If there is a metal in the formula, then that means it's an ionic compound, and it's going to follow the naming that we've been doing up until this point. And it's not a molecular compound, so you really have to have your periodic table in front of you in order to do this. So naming molecular compounds. So the next step is you're going to change the ending of the second element to IDE, which is just like what we've been doing. And you're going to add prefixes that show the number of each element. So you have a table in your packet with mono and the number of 1. And so that would end up when an example would be carbon monoxide. Di for 2 would be carbon dioxide. Tri for 3 would be sulfur trioxide. Tetra for 4 would be carbon tetrachloride. And penta for 5 would be phosphorus pentafluoride. Now in your table, they do not put the prefixes for 6, 7, 8, 9, and 10, but you do need to know those because they are common enough that they're important. So for 6, we have hexa. 7, we have hepta. 8 is octa. 9 is nona. And 10 is deca. And hopefully you'll recognize that most of these prefixes are very similar to ones that you already learned in geometry, like octagon and decagon and hexagon and heptagon. All of these are very similar. So hopefully these aren't too hard for you. So naming molecular compounds, we have an example here. Name the molecular compound with the chemical formula PCl3. So first we're going to double check that there is no metal in here. So both phosphorus and chlorine are all the way over on the right-hand side of the periodic table. They are both nonmetals, so we're good to name it this way. So we're going to write the names of both elements in the same order as seen in the formula and replace the ending of the second element with IDE. So that's going to be phosphorus and chloride. And then we're going to work on adding the prefixes. So the second step is to add prefixes. Remember that the prefix mono is never used for the first element. So this is the first time you're going to see this. So first element, we never use mono. And probably the easiest way to remember this is that CO2 is carbon dioxide, and you guys have known that for a long time. We don't say monocarbon dioxide. We just say carbon dioxide. So again, here we have phosphorus and chloride. So there's only one phosphorus, so we're not going to put mono there. Chloride, there are 3, and our prefix is tri. So we're going to have phosphorus trichloride. So that is the name of our compound here, phosphorus trichloride. Let's try a few more. So we've got Ni3. Again, stop and make certain these are both non-metals. So it's nitrogen and iodine, so nitrogen iodide. And since there are 3 of these, it's going to be nitrogen triiodide. And yes, you have the double I's there. The next one, we have CCl4, so it's carbon and chlorine, which is going to be chloride. There's 4 of them, so we've got carbon tetrachloride. Next one, oxygen and fluorine. Those are both nonmetals. So we've got oxygen fluoride, and there are 2 fluorines, so that is going to be di. So it's oxygen difluoride. Next one, phosphorus and oxygen. Those are both nonmetals. So there's 2 phosphorus this time. So this one's going to be diphosphorus. And what's the prefix for 5? It is penta. So diphosphorus pentaoxide. Okay, taking a look at the next one. N2O3, we have 2 nonmetals. So dinitrogen trioxide. Take a moment and pause and see if you can do the rest of these. So the next ones, we've got carbon monoxide, carbon dioxide, and phosphorus pentafluoride. Hopefully you are finding these easier than the ionic ones. Okay, so now going the opposite, taking the name and writing the formula. So simply write the element symbols down in order and then use the prefixes to determine how many of each element you have. So for the first one, we have carbon, which is C, and oxide, which is O, and there's only 1, so that will be CO. The next one is sulfur, which is S, and fluoride, which is F, and tetra is 4, so we get SF4. The next one is dinitrogen tetroxide. So we have 2 nitrogens and 4 oxygens, so it's N2O4. We do not reduce here, Okay, this compound naming tells us exactly how many of each atom you must have, and this has to do with the sharing. So these are not reduced to a simpler form when they're named in this covalent naming procedure. So this is very different from the other one. You may want to make a note somewhere along the side because this is your first example of that. Then we have nitrogen tribromide. So there's one nitrogen and there are 3 bromines. So you should have NBr3. So pause the video for a moment, do the other 4. And I got CS2, SO3, N2O, and PCl3. And I'm hoping that you find that this is much easier than the ionic. So there's some common names for molecular compounds, and a couple of these you are just going to see throughout time. So water is H2O, ammonia is NH3, nitric oxide is NO, and hydrogen sulfide H2S. So these are common names. Now the 2 that you probably really want to memorize is water, which is H2O, which you already know. But ammonia, I'm guessing, is one that you might not know. Now notice this is not the ammonium ion. It's not NH4 with a positive 1 charge. It's ammonia, just like you would buy at the store a bottle of cleaning ammonia. So practice for you for covalent compounds. So you're going to be working on pages 25 and 26. And notice in the middle of the columns here, it has if it's ionic or molecular. So you are going to have them mixed up here. You have to pay attention to the fact whether you have a metal or not. So as you go through these, check and see if you have a metal or a polyatomic ion, because if you do, you have to follow the rules that we did previously. If you don't, and you have 2 nonmetals, you're going to do the covalent naming that we just did with the numbers. Okay, so those are the 2 pages you're going to be doing for homework where you're going to be practicing these. All right. So that's all the new material. So I wanted to point out on the naming spinner where this information is. So you have on your naming spinner on the inner circle here, molecular compound prefixes. It has mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And it's covered up on my picture here. Sorry about that. But the section that says molecular compound has the information underneath that would be showing if I had spun it differently. But this is the same picture I showed in a previous class. This has the information about how to name molecular compounds. The other place where you have this is on the chemical nomenclature sheet that we were using previously. It has these prefixes on the back, and it has the information here that for mono, you don't use it with the first nonmetal, and the preferred form of monooxide is monoxide. We don't double the O there. So you have these resources and these references. I strongly recommend that you retain these references for your use for next year. I do not know which teacher you're going to have. I know they both do different things with this, but keep these, whatever's helping you, so you have these resources available to you next year. So your turn-in work. You've got worksheets, recording your reaction observations from the penny and hydrochloric acid video, which I hope you enjoyed. Purple packet, pages 19 and 20. Again, you don't have to complete those, but do some of them. And then purple, pages 21 through 26, which is what we just were working on with the covalent bonding. And the survey, which I haven't finished, so I don't have the link in here, but it will be posted. Bookwork, optional bookwork. So today we did binary compounds containing only nonmetals, which was in section 5.3, of which I only put 1 question down. And then 5.4 has all of the different types of compounds all mixed up. So that's additional practice. And then section 5.7 is writing formulas from names. And we've been doing this as we've gone along. Your book just takes naming and then at the end puts this really short section about how to get the formulas from the names. We kind of do them at the same time. I think it makes a little bit more sense. So those are the optional book work. So looking ahead, I've scheduled some additional practice Zoom sessions for anyone who wants to attend, and just want to let you know they are not mandatory. They're totally optional. Doesn't count against you if you're not there. So days and times, I've got some days and times listed here. I know I saw a lot of people with things in the afternoon and a few things noontime and later. My daughter is taking AP testing this week. She actually has had one Tuesday, and now she has one Wednesday, Thursday, and Friday. So I have to be sure I'm not trying to do a Zoom call at the time that she's taking tests. So I've got these kind of scheduled around her time frame as well as my husband's time frame. Next week, I will put a few other ones. I did put one on the weekend. I know a lot of you said not on the weekend, and that's fine. And if nobody shows up to join me, I will do some other work. But I wanted to throw those out there. I'm only planning on spending 30 minutes. Again, some of these days I have to get off the Wi-Fi, but I just wanted to have those as an opportunity for you. So comment on your creation project. May 19th, you're going to have 2 more resources due. I wanted to tell you when I was looking at these, I just want to say they have improved so much from the fall. Your writing is better. You're writing using scientific terminology that you weren't comfortable with in the fall. So many people are finding unique resources. They're not using the first one that pops up, which is also obvious because out of the 48 of you, it used to be like 30 of you or 35 of you would pick the exact same video for the same exact topic. And now we're finding all sorts of different things. So this has improved so much, and I can really see your growth over the course of the year as I'm looking at this curation project and your writing. So you guys all should be commended and feel good about that. Looking ahead, end of the year, I can't believe it's this time already. Turning in textbooks. So I have requested from administration, and I'm waiting for final approval for you guys to not turn in your chemistry book. The reason is multifold, but the biggest ones are you're going to use these again in the fall, assuming you're returning to Beaumont. And with this whole COVID thing and having to sanitize and clean and all of that, I don't think it makes any sense for you guys to turn this book in when you're going to need to get it again in the fall. And then it's one less thing that Mrs. Holzel is going to have to deal with and address. So I don't have final approval yet. I'm still waiting for the rest of the admin. I've already got a few people saying, yeah, I think that's a good idea, but it's not, I don't have the final approval. So anticipate right now that that's probably going to be approved. And along the note of looking ahead, so I have your coin, your copper penny, that I'll need to mail to you. So I'm going to need your mailing address. And I have found through the year, a few people have moved and they're not updated in PowerSchool. So I'm going to end up putting that as an item on your surveys so that eventually everybody should have given me their street address. And I don't know if I've told you, but how much I really miss each and every one of you. It's really been an interesting and challenging year, and I really don't know how to express my feelings about you guys. But you guys have done so well under this COVID crisis. It has always been interesting for this class because it's a big transition between biology and this class and doing physical science. And the fall is a struggle, and you're trying to do physics and the mop apps, and I get it. And we start chemistry, and we're just about ready to start labs, and then we're sent home. But you guys have really done well, and I can't tell you how proud I am of all of you. I know that some of you are struggling more than others. Some of you are struggling a lot, and I appreciate you being communicative with me and telling me what's going on. And even though we've been apart, in some ways, I kind of feel closer to you than I did previously, partially because of you guys filling out the surveys. I feel like you guys are, sharing with me maybe things you wouldn't have shared if we had been in class. I've taken all of your comments. I've read all of your feedback, both good and bad, to heart, and I have really tried to do my best for you. So, ladies, I can't believe that we're like winding down here to the end. It's really kind of weird. So, thinking about the summer and next school year, I don't know what's going to happen. I wish I had some idea. I think the predictions are everything from we'll be back to school as normal to we won't be in the school building at all. So I don't have any idea of what to predict or what's going to happen during the summer. You guys need a break. However, I will say that you will help yourself out in the fall in chemistry, especially if we're not in person, by looking at some of these things, particularly these things here at the end, the naming stuff, and then the balancing equations. So I will do a little bit of interaction and some suggestions for you guys in the summer. Also, if we're all still kind of quarantined, I am going to be happy to have some Zoom meetings just to say hi and see how you guys are doing. So, feel free to reach out to me, anything that I can do, anything that I can help you with. So, ladies, that's it for today. So this is on Wednesday. I will keep on working on your tests, and I will be in touch soon. So, ladies, keep up the good work. Hang in there. You've only got a little bit longer to go, and I will talk to you in a couple days.